Hi there, my name is Girish Jaju. In this video, we will discuss about S3 presigned URLs and also implement a serverless solution to generate the same. What is the need for S3 presigned URLs? We know that we first create the S3 bucket. The bucket is private, meaning only the owner or the creator has access to the bucket and its objects. What if we need to share the objects with some other user or applications, which may or may not have IAM accounts or roles? How do we do it? This is where the S3 presigned URLs come handy. These URLs are generated by using S3 APIs and are accessible for a limited duration. We do set the expiration time. Users or applications can use these URLs to access or upload objects to the private S3 buckets that are owned by you. The presigned URLs only have permissions that you associate with them while creating, like get object or put object. In this tutorial, we will implement a serverless application that will expose an endpoint to be called to generate a presigned URL. We can use any application that can call an S3 API to generate these, not just a serverless application. In this demo, as I mentioned, we will expose an API endpoint via Amazon API Gateway. A user calls the API endpoint to generate the presigned URL. The API endpoint is integrated with the Lambda written in Node.js, which makes use of the S3 APIs to generate the presigned URLs. Once the URLs are generated, they can be used to access or even upload the objects in the private S3 bucket that we own. Let's implement this. Now we are ready to create our serverless application. So I am in my Visual Studio Code and I have a folder called YouTube S3 Presigned URL demo. It could be any name. Let's initialize an npm application. So should get our package.json file here. We'll create a serverless and use the serverless framework to create this application. So SLS create NST, and we will use the Node.js template. So AWS Node.js, which will give us the boilerplate serverless YAML. So let's clean up and start modifying this file for our needs. If you scroll to the bottom of the file, you will see there is a resources section. We'll uncomment this. This is where you can put any CloudFormation code that your application needs. So let's give bucket a name which should be globally unique. So I'll just say my cloud tutorials YouTube S3 Presigned demo. Hopefully that name is available. We will also AWS recommends that we should have the bucket and the policies not publicly open. So we'll write some of the policy document. So for example, block public ACS to true. We'll also have block public policy to true. We'll have ignore public ACLs true, and lastly restrict public buckets as true. Okay, so this should create, let's call our resource my S3 bucket, or let's call it demo bucket, for example. Let's go to the provider section. This is where we will add stage. By default, serverless framework deploys it in dev, so we'll just keep it dev. And also the AWS region, I want to be in US West 2, Oregon, which is the closest region for me. So we got that. Let's remove this. Once you have that, let's see, our Lambda function needs to be able to connect and run the S3 APIs to this bucket. So let's give some IAM rules. So let's say IAM role statements, and effect should be allow. Now what are we allowing? We are allowing action should be, we are allowing S3 get object and S3 put object, API call object. Now, are we allowing on all the entire S3 bucket or on certain resources? Let's just give particular resources on which we want to allow this. Now, this resource takes the format of bucket ARN /star. How can we do that? So we have to join. We can use intrinsic function join, and join separation separated by slash, and what is the resource ARN. So we can use another intrinsic function called get att, and the get att take your resources ARN name, and our resource name is demo bucket. So you can go to get att demo bucket dot ARN and applies to all the objects in that bucket. So what it's doing is going to print or resolve to a bucket ARN /star. So all the objects within the bucket. That's what we need. Let's go to the function section, and this is where we will write our function. So let's name it, for example, generate presigned URL. Now this will take the bucket name to work on. So we'll just pass it as an environment variable. Let's call it bucket name, and again we'll just pass it as an intrinsic ref function, which is called demo bucket. The function should actually be invoked from an API. So let's say events, and the events, we are saying this should be invoked using HTTP event, and the path for that event, let's call it presigned, and method should be post, so that it can take the body and generate a presigned URL for us. So we don't need all of this. So let's clean up a little bit. Okay, so let's now go to our function, and we'll just write this function here. So if you go to handler, I don't need this hello, so I'm just going to remove this, and I don't need this either. So let's start with getting some of the libraries that we need. So we need the S3 client, and you can get it acquire AWS SDK /clients /S3. Our bucket name would come from the environment variable, so let's call it bucket name, and it will come from process.env.bucket name. Let's initialize the S3 client. S3 equals to new S3. Okay, so this is good. Now in our function, let's start with a try, and let's say catch. So let's, if any error, let's log the console log it. Console.log error. Okay, and then we'll return, in case of error, we'll return status code. $500, and maybe a body or a message in the body. Let's say, please check the logs. Okay. Here we'll process, let's say, first parse the body that is coming back to us. JSON.parse event.body. Now this body has certain elements that we send in. So one of them is object key equals to body.object key. We also need the S3 action, body.s3 action, and we can also have optional content type, which is body.content type. This would be needed when we create a pre-signed URL for put requests. And the generated URL takes expiration time. So by default, let's see, expiration time is 60 seconds. Let's create the parameters object. Let's say params equals to, now this parameter object will be passed to the S3 API. So it takes bucket as bucket name. It also takes key as object key, and also takes expiration time. We might want to give them a little bit longer expiration time if it's a put object request, because we are going to be creating some curls and it would take some time, and we don't want our generated URL to expire before we can even take an action on it. So let's see. So if S3 action equals to let's say put object, in that case we can say params.content type equals to the content type that is passed in the request, and you can also say params.expires to, let's make it 5 minutes, so let's say 300. Looks good so far. Let me just minimize this. Now we make the S3 API call to generate this URL. So we say cons signed URL equals to S3 dot get signed URL, and it takes two parameters. One is S3 action, and the other one is the params object that we created, which takes the bucket name, key, and the expiration. Once everything is good, we can return from here, and then we return status code as 200, and in the body we will just return the stringify value of the generated URL. So json.stringify, and the URL generated is signed URL. Okay, let's try to deploy this, and if any error, then we'll troubleshoot. So to deploy is simple. You just SLS deploy. So let's head over to my management console, and here I have some CloudFormation stack. A new formation is just started, YouTube S3 Presigned URL demo, and let's wait for it to finish. So you see the new bucket is created. Let's just filter it on YouTube. And let's just wait for it to finish out. So it's creating all the resources. As you can see, if you see the resources section, it has already created the API gateway. It has created demo bucket and a log group. Actually, we did not change the name of the function, so it's just a hello log group and the serverless deployment bucket, etc. Let's go back to our Visual Studio Code. So it's still in progress, and in the meantime, we can create a couple of sample files. So let's call it, let's say we'll create a simple HTML file. Let's call it sample.html, and this is a sample HTML file to test get object presigned URL. Let's create one more file. I call it sample1.html, and this is what we'll test to do put object presigned URL. So our endpoint is ready. As you can see, the CloudFormation stack creation was successful. Let's go to our bucket and refresh this, and we have this mctu s3 presigned demo. So let's upload this file here, and I'll just also want to show you the permissions that we set. And if you see here, we have blocked all the public access and all the ACL, etc., so that our bucket and the objects cannot be accidentally made public. So what we'll do here for this demo, we'll upload the file that we just created, sample.html. Let's go to sample.html, I'll open it and upload. Upload was successful. So let's see, if I go here, this is the object URL. So if I try to open it in a new tab, this is what I get, access denied, because all the objects and the bucket are private. Now let's try to use our API that we created to generate the presigned URL and try to access this file using the presigned URL. So to do that, let's go back to Visual Studio Code, and this is the endpoint that we have. And what we'll do, we will actually, I have a couple of Postman requests ready. So what we'll do here is replace this with the URL that we just got. And here, this is the file that we have. So I'm sending this object key and the S3 action in the request body. So let's try to generate the presigned URL. Okay, so URL is generated, and you can see in the URL, you have the access key ID, the expiration time, and the signature. And you know that we set for the GET request, we set the expiration time to be 60 seconds. So let's try to open this using the presigned URL. And yes, we are able to see the sample file that we uploaded. If we wait a few more seconds and try to refresh this URL, this link would expire, and then we should see the error again. So let's just wait for a couple of seconds. Still good. Still good. So I think we give 60 seconds, so it would be another few seconds left. And yes, once the expiration time is passed, you can no longer access this file from the URL that is passed. Okay, so that was the get object S3 presigned URL. Let's try to upload a file using a presigned URL. So there could be a situation where you want to, you have clients who needs to upload the files in your S3 bucket, and you don't want to, of course, give them permission to the S3 bucket, but you can give them a presigned URL so they have temporary credentials to upload the files. So let's see how we can mimic this. So going back to our Postman, let's try to create S3 presigned URL for put object call, and in this case my object key is sample1.html, S3 action is put object, and content type is text.html. Let's see our S3 bucket one more time, and if I refresh this page, we should only have one file yet. Okay, so what we'll do here, we'll try to generate a URL for, I have to copy the API endpoint that we just created, and we'll try to generate the endpoint for this. Okay, so we got some error. Let's see. If you go to functions and let's go to monitor and CloudWatch. Okay, so unexpected content type, I think that I have a typo, and it should be content type with C capital. So let's fix that. Let's redeploy. Okay, so the stack is finished. Let's try our request again to generate the presigned URL for put object. And yes, we got that. So what we'll do, we will try to write a simple curl command to upload this file. So in -h header, we'll say content type is text.html, and this request is of type put. And what are we uploading? We are uploading this file called sample1.html, and in the end we will just give the entire presigned URL path, and it returned with nothing. That means success. So let's check our S3 bucket. If I refresh, and yes, I see the sample1.html file got uploaded. Let's try to access it using the object URL first, and obviously I got an error because the bucket objects are not public. So let's try to generate a get object for this file that we just uploaded. If I try to access the file using this endpoint, I should be able to get it, and this is a sample file that we created. So this concludes the demo, which shows how we deployed a serverless application to generate S3 presigned URLs for both get object and put objects, and how we can use this URL to get or upload the objects into our private S3 buckets. These URLs expires based on the expiration time that we provide, and let's do some cleanup. So first thing first, before we do the cleanup, we will actually be deleting the CloudFormation stack. So let's go to S3 bucket, because the CloudFormation will not allow us to delete the S3 buckets if there are content in them. So we'll delete this, and let's copy command and delete. So S3 bucket is empty. There is another S3 bucket that we have where the CloudFormation stores the CloudFormation data. So let's empty this bucket as well. Once the buckets are clear, we can go to CloudFormation stack, and while you're in the stack, you can delete the stack. This way we don't get accidentally charged for the storage or the CloudWatch logs or anything of that sort. So delete is initiated, and once delete completes, we just wait. It should be completed in a few seconds, and let's check the events. So yeah, its delete is completed. I hope you like this demo, and I'll be looking forward to seeing you in subsequent videos. I'll be creating some more demo videos. Please subscribe and like this video, and thank you so much for watching. See you next time.